Yeah, hi everyone. New problem. As usual, LPP formulation. Formulating the problem by separating the objective functions and the constraints. First, the problem. A transport company is considering the purchase of new vehicles for the transportation between Delhi airport and hotels in the city. There are three vehicles under consideration: station wagon, minibuses, and large buses. The purchase price would be rupees 2,45,000 for each station wagon, rupees 3,50,000 for a minibus, and rupees 5 lakh for each large bus. The board of directors has authorized a maximum amount of rupees 50,000 for these purchases. Because of the heavy air travel, the new vehicles would be utilized at a maximum capacity, regardless of the type of vehicles purchased. The expected net annual profit would be rupees 15,000 for the station wagon, rupees 35,000 for the minibus, and rupees 45,000 for the large bus. The company has hired 30 new drivers for the new vehicles. They are qualified drivers for all the three types of vehicles. The maintenance department has the capacity to handle an additional 80 station wagons. A minibus is equivalent to 5 by 3 station wagons, and a large bus is equivalent to 2 station wagons in terms of their use of the maintenance department. Formulate and solve the problem as a linear programming model to determine optimal number of each type of vehicles to be purchased to maximize the profit. So before getting into this problem solution, I just want to bring to your notice the two different solutions which is given in two different textbooks. Problem is the same, but you find out two different solutions. You see, this is regarding the maintenance capacity. The first solution says x1 plus 1.67 x2 plus 0.5 x3 is less than or equal to 80. And second solution says x1 plus 3 by 5 x2 plus 1 by 2 x3 is less than or equal to 80. Now you find that the minibus constraint 1.67 x2 is in the first solution and 3 by 5 4.6 x2 is in the second solution. So you know that in LPP there cannot be more than two solutions to the same constraint. So we require to find out which one is the correct one. So it turned out to be that both the solutions are wrong here. So just wanted to bring to your notice that there can be, textbooks sometimes can return wrong solutions, not because of any other reason, because of proofreading mistakes or printing mistakes. This is not to find a fault with anybody. This is just to bring to your attention that these kind of mistakes can happen and we need to correct it. Now to the solution. So this particular solution, we need to consider that station let there be x1 solution, x1 number of station wagon, and x2 number of minibuses, and x3 number of large buses. So this is what we are assuming. Now we need to find out what is the objective function and what are the constraints. So first, the objective function. Here the profit is given that 15,000 for station wagon and 35,000 for minibuses and 45,000 for large bus per unit profit. So we need to find out the objective function as profit maximization. So maximize Z is equal to 15,000 profit for 1 unit of station wagon. So we have x1 unit of station wagon. So it is 15,000 into x1 total profit fetched by station wagon, and then 35,000 for 1 unit of minibus. or x2 unit, 35,000 into x2 is the total profit fetched by the minibus, and then 45,000 for large bus, 45,000 and into x3 is the total profit fetched by the large bus. So maximization is over. This is the objective function. Now we need the constraints subjected to constraints. So first constraint is of course the cost constraint, which is given 1 unit of station wagon, the cost is 2,45,000. So the total cost for X1 unit of station wagon is 2,45,000 into X1. Similarly, 3,50,000 is the cost for 1 unit of minibus. So total number of minibuses are X2. So total cost for X2 units of minibuses is 3,50,000 into X2. And then total cost for X3 units of large bus is 5 lakh, that is the single unit cost, 5 lakh into X3, that is for X3 units. Total available budget is 5 lakh. Sorry, it is 50 lakhs. So this is budgetary constraint. Next, the labor constraint. Total 30 drivers are there. All the 30 drivers drive all kind of vehicles. So there is no separation between, discrimination between station wagon or minibus or large bus. So X1 plus X2 plus X3. Total number of vehicles cannot be exceeded 30. Otherwise, if it exceeds 30, some buses, some vehicles will be idle. Next is the maintenance constraint, and fourth one is non-negative constraint. So budget maintenance constraint we need to calculate like this. Total 80 station wagon can be serviced in their facility. So in the total one facility is there, and 80 station wagon can be serviced. So 1 unit of station wagon require 1 by 80 of the facility. Now we have minibus. It is said that minibus is equivalent to 5 by 3 station wagon. So 1 unit of minibus require 1 by 80, that is space facility required for station wagon, multiplied by 5 by 3. And then 1 unit of large bus require 1 unit of station wagon multiplied by 2. That means 2 minibus is equal to 1 station wagon. So this is the per unit requirement of the maintenance facility. So now for X1 unit of station wagon require 1 by 80 into X1, because 1 unit of station wagon require 1 by 80 facility. 1 unit of minibus require 1 by 80 into 5 by 3. 1 by 80 multiplied by 5 by 3, and for X2 it is into X2, plus 1 unit of large bus 1 by 80 into 2, and X3 unit it is into X3, 1 by 8 into 2 into X3, and total available is 1 facility. Now if you multiply with 80, you will get X1 plus 5 by 3 X2 plus 2 X3, which is less than or equal to 80. So this is the non-maintenance constraint. What is maintenance constraint? X1 plus 5 by 3 X2 plus 2 X3 is less than or equal to 8. So previous solution, it was giving us, the textbook solution was giving us 0.5 x3, but it is 2 x3 in actuality. This is correct. 5 by 3 is 1.67, which when you divide. So you can write it as x1 plus 1.67 x2 plus 2 x3 is less than or equal to 80. A non-negative constraint is x1 and x2 and x3 will be greater than or equal to 0, and hence the solution. Thank you.